Hello, today I'm going to outline how you can make a world for use in the Amaze II package on the ESP32. I'm going to assume that you already know how to use Blender and just give a few tips. The starting point is to make a large plane the size of the area that you want to produce. You can adjust this quite a lot later, so this is very much developing a framework. A critical part is then to subdivide this area into 10-meter square chunks. The base plate won't display properly if it isn't divided, and equally each of these squares gives you guidance on where to place elements. When you've got your plane made, you can adjust the faces and vertices to give your world a three-dimensional appearance. You can be as creative as you want here. A key point is that the vertices on the corner of each of these 10-meter squares should not be moved in the X and Y direction. However, if you need more detail, feel free to subdivide these planes and then you can adjust each of those individually. And actually, the vertices within a 10-meter square can be adjusted on the X and Y coordinates without disturbing the chunking. This gives you an ability to make quite a detailed landscape. When the player makes a sharp descent, their energy is reduced. So including depressions and pits is a way of increasing the complexity of gameplay by making areas that are dangerous for the player to enter. Descending down a gentle ramp does not cause an energy loss, and so careful navigation can be required around the world. You can then be creative with the colours applied to the various faces in your world. You might adjust the colour dependent on altitude or its inclination. Again, faces can be subdivided to increase the level of granularity applied. I'm going to make this land a small island, so I've created a margin and added a beach area. This can be done on a circular area which looks far more effective, but is a little harder to put together. To give the player an ability to cross over this deep inlet without falling into the river, I'm making a bridge which crosses over from one side to the other. This bridge will also form part of the base area, so the player can walk over or potentially under it. Although it's possible to add quite a lot of colour and variation to the scene through dividing it into facets and in colouring each one of them separately, textures can be used to add detailed structures. I don't recommend using textures for block colour, as textures take longer to render by the ESP32. Free seamless textures are available from various resource sites online. You'll need to learn how to manage textures and UV mapping in Blender to do this effectively. This is something that I haven't yet mastered. Now we've got some depressions, we can fill them with water. A plane is made that lies at a level between the base of the depression and the normal ground level. It should be big enough to cover all of the borders. You'll find that it automatically develops quite a broken up border based on how the land contours round. If a large piece of water is made, this plane will cover more than one chunk, and so is at risk of not displaying or behaving correctly. So once the water is positioned across several chunks, it should then be subdivided up to ensure that it displays and behaves correctly. This also gives you the opportunity to add a more dynamic effect to the water. By adjusting the height of the vertices, each of the individual subplanes will reflect light slightly differently. I'll show you perhaps in a later video how you can make this into a dynamic effect so the water appears to ripple. The bridge is large and crosses at least 3 chunks as shown by this 10-meter square. so the bridge needs to be divided up. I'm going to put on the snap function so to divide it in the right place. The chunking algorithm does allow objects to not fit precisely on chunk borders, but in general you will achieve a better result by having the chunks as aligned as well as possible. Blender will automatically correct for UVs on the broken up primitive triangles, and so this is an effective way of breaking your objects up. Now, it would be nice to have some movement in the world, so I'm going to make a small animated ball. This is done using the normal animation functions in Blender. A key point is that the first frame should be on frame 0. When this is exported, the 0 will be used by the conversion program to recognise that the object file really is an animation. I'd recommend not having more than 20 frames in the animation. I've chosen to have 10. So you make the 11th frame match the first frame, so the whole system loops neatly. Now we have all of our components in place, these need to be exported. The components that comprise the base should be exported as one object. I often just name it with base to make sure that I remember what it is later. Make sure that the flags are set as indicated. Next, any static items are exported and often named as the rest. Finally, animated objects are exported. It's important at this stage to make sure that you've set the animation information to indicate the first and last frames that you want exported. So now when we go to look at what we've got a whole range of object and MTN files for the animation, the rest of the object and the base. Now we can go to the conversion routine. Enter the file names that you have in here, making sure the base one goes first, and also enter the start point and the direction that the player is looking. Here we can see the wood textures that I've used, and you can see its file name. It's important that that name matches the name in the MTN file. When we run the Node.js application, the file will be converted. You can scroll back through the debug output to see various messages of what's going on inside the process, but these are not necessarily self-explanatory. Now we've got the binary file, we can flash it to the ESP32. Make sure you've suspended the terminal output or this process will fail. The binary file should be added to the world partition and it'll take a moment to upload. Once it's uploaded, the program should restart and display your current world. Some little extracts from this world show us going over the green hill and looking into the distance. Now we're on the beach. And we can make our way round to find the water inlet. And there's the water inlet with the plank which we can make our way across. We can have a little look round and show that we are truly on the plank above the water level. So let's finish off crossing over the inlet. And if we hunt around, we'll find our little bouncing ball. You'll note this is quite shiny because the roughness value was set low. Good luck, and I look forward to seeing what worlds you make.